Page IN40, we are going to look at a lesson on volume of pyramids. So volume of pyramids, you guys have a reference sheet. And again, for the iLearn test, they will not give you a reference sheet, but they will provide you formulas as needed on the test. So volume of pyramids, if you look on your formula sheet there, we have a formula for the volume of a pyramid. It's 1/3 BH, capital BH. So capital B, when you see that on the formula, capital B, that means the area of the base. That's the area of the base. So different bases we might see problems where our base is a rectangle. So you need to know, which I think you do by this point, the area of a rectangle is length times width. We could have problems where our base is a triangle. And again, I think at this point you guys know the area of a triangle is 1/2 base times height. Notice the area of a rectangle, area of a triangle, those formulas are not listed on that sheet of formulas that will be provided for you. So you will need to make sure you remember what those formulas are, both for your test and for the iLearn test. So last year, you did some stuff where you found, really the last couple years, volume of a rectangular prism. And you may or may not remember, volume of a rectangular prism was length times width times height. In this case, we might have the volume of a rectangular pyramid. So rectangular pyramid would be a pyramid where the base is a rectangle. And it works out, that was length times width times height. Think about it, your base is a rectangle, so this is really like area of the base times the height. With the pyramid, it's 1/3 of the area of the base times the height. So by it coming up to a point, it's pretty crazy, but it works out like if you had the same base on a rectangular prism and a rectangular pyramid, the volume would be exactly 1/3 of what it would be if it was a prism. Okay? So this would be like 1/3 length times width times height. So really the 1/3 is the only difference between the pyramids and the prisms. You don't really need to worry about that, but I'm just trying to show a relationship between this and what we've already talked about. So let's look at example 1. Students in the art club are using a candle mold to make pyramid-shaped candles. 1 pound of wax can fill 36 cubic inches. How many pounds of wax will the students need in order to make 50 candles? All right, so you can see the picture here. We have, you could technically call this a square pyramid, or less specifically, we could call it a rectangular pyramid. Anyway, this part is basically where we're at. The book, they just keep it as 1/3 capital BH, and they just say, well, capital B, that's the area of the base. If you want to do that, that's fine. Another option is, since our base is a rectangle, and we just talked about the area of a rectangle is length times width, you could change it to this and then say, well, my length is 6, my width is 6, and my height is 6. And then you could just multiply those all together. So multiplying the 6's together is 216. You know, the 6's you could put over 1's. And then it's like if you multiplied straight across, you would get 216 over 3. And then if you divide that out, you get 72. So 72 cubic inches would be the volume. Volume, we've talked about before. Basically, it's how much space something takes up, or how much you could fit inside of something is volume, okay? We're not talking about volume like how loud something is here today, just to be clear. So anyway, that's 72 cubic inches. And it says that says that 1 pound of wax can fill 36 cubic inches was given to us. So what we could do here, we could do kind of a proportion. So we've got 36 cubic inches for 1 pound of wax. We know our volume is 72 cubic inches. So this would be like our X spot. If we were working this out, we'd put X there and we'd be figuring out, or you put a blank there, and then you could figure out going from 36 to 72, it'd be multiplying by 2. Okay, 72 divided by 36 is 2. So then to get something proportional, multiply the denominator by 2. That would mean 2 pounds of wax for each candle. So if they want to make 50 candles, so it's 2 pounds for each candle. They want to make 50 candles, we'd need 50 times that, or we would need 100 pounds of wax in order to make 50 candles. Okay. And these are some good problems. You know, realistically, try to make an application to something, and then just, instead of just saying, what is the volume of this pyramid? Okay, trying to apply it into a situation like this. This is more likely the types of questions you guys will see as we get into things more. So on the try it, we've got a similar situation. Art teacher has a second pyramid-shaped candle mold, has a 4-inch square base and a height of 6 inches. How much wax is needed to make a candle from the second mold? Okay, not quite as much application here on this problem. So what I would probably do is just start out with that formula that you'll be given. So this formula will be given to you, and then you just have to remember what the capital B means. Capital B means the area of the base. In this case, the base is a square, which is a type of rectangle. Area of a rectangle is length times width. Good. All right, so this is what we're going to be doing to figure out this volume. Since we have a square base, we know length and width are both the same. Length and width are both 4, and the height 6. And then we'll just try to simplify this. Again, those 4, 4, and 6, you can put those over 1 if you want, and then just multiply straight across. So if we just multiply straight across here, we should get 96 over 3. And then 96 divided by 3 comes out evenly as 32. So that means 32 cubic inches for each of these candles. And that was all they asked us to do for that problem. So example 2, some students in the art club found a candle mold in the shape of a triangular pyramid. How much wax is needed to fill this mold? So this one, since it's a triangular pyramid, you can start with your formula. And then, since the base is a triangle, we've already talked about the area of a triangle is half base times height. And this gets a little interesting because we actually have two heights we're talking about, the height of the triangle and the height of the pyramid. So at that point, I'm going to go ahead and change the second H to a capital H for the height of the pyramid versus the lowercase h is the height of the triangle. Anyway, what you can do actually on this problem, even before you get started here, you got two fractions in front. You can go ahead and multiply those together. So 1/3 times 1/2 would be 1/6. And then on our triangle, you might say the base is 6 and the height is 8, depending how you're looking at it. And then the height of the pyramid is 12. And then those whole numbers, you can put all those over ones. Technically, the 1/6 and the 6, you can actually reduce both of those by 6 since you're multiplying. But anyway, if you don't see to do that, you can just multiply it, get a number over 6. And then when you divide, they've got it coming out as 96. So if we would have multiplied the 6, 8, and 12 together, you get 576. And then if you divide that by 6, you will get 96. Okay. Again, all these problems, I highly recommend that you start with the formula, then you substitute, and then you start working things out. The more steps you're skipping, the more chances of making a mistake when you do these problems. So if we look at the try it, kind of a different setup here is that they're actually giving you the area of the base. See that capital B there? So they're already telling you the area of the base is 36. And then the height's 10. So this is actually really less work for you. We'll make sure we look at some where they don't give you just the area of the base for these triangles, so you get practice with that also. So just multiplying straight across, this would be 360 over 3. And then when you divide that out, it would be 120. So 120 cubic centimeters. When we're doing these, talking about volume, they're always going to be cubic units for volume, because it's like, how many cubes can I split this up into? It seems kind of weird, some of these shapes, how we could fit cubes inside of here, but that's, you know, some of them we'd have to cut up and stuff, but that's basically how it works out. So example 3, what is the volume of the square pyramid shown at the right? And you might think, well, we already did this. Well, this one's a little different, because if you look at the picture, we don't know what the height is. The height of a pyramid is like how tall it is, straight up and down. That 10, there is a term for that. The 10 is what's called the slant height of this pyramid. But anyway, we don't need that. We need the height. So we get to use the Pythagorean theorem. Okay, in other words, I can make a right triangle out of this. The 10 is the across from the right angle, so that's the hypotenuse. Now the 8, you might say, well, where did they get 8 from? Well, 16 is all the way across. This is all the way across. So if this triangle goes halfway across, then that would be 8 inches. Okay. You know, 16 divided by 2 is 8. That's how they got that one. All right. So anyway, a squared plus b squared equals c squared. It's been a little bit on that maybe, but h is one of the legs, so you can put that in for either a or b. 8 squared, 8 times 8 is 64. 10 squared, 10 times 10 is 100. And then they're not showing all their steps here. If you remember, we would next subtract 64 on both sides. So h squared equals 36, and then they're squaring, so we would do the square root. Technically, when you do square root, you should add the plus or minus sign in front of that. When we talk about the height of a pyramid, the height can't have a negative. We can't have a negative height on our pyramid, so that doesn't make sense. We can cross it out. So anyway, it looks like 6 inches would be the height of our pyramid. Now that we have that information, now that we know the height is 6 inches, we can go back to our formula. And again, the formula, if you want, like I've been talking to you about, you could go and say, well, our base is a square, which is a type of rectangle, so area of a rectangle is length times width. And then I can substitute in length is 16, width is 16, height is 6. And then if you multiply straight across 1,536 over 3, divide it out, you get 512 cubic inches. So very similar to what we did earlier, just a little twist there that we had to figure out the height first by using the Pythagorean theorem. So, very similar problem here to get some practice. What is the volume of the square pyramid shown at the right? So again, this is very, very similar to example 3 we just looked at. So for our volume, we know it's 1/3 times the area of the base times the height. We know our base is a rectangle or square here, so length times width. So at this point, we know the length and width are both 6. The problem is this height. I want the height to be straight up and down the pyramid. That's not what we have. We have what's called the slant height again. So what we can do here, though, we can form a right triangle, and we can use our Pythagorean theorem. So a squared plus b squared equals c squared. Remember, c is the hypotenuse. It's the longest side, and it's always across from the 90-degree angle. So 12 would be our hypotenuse. The height is one of the sides we're trying to find. And then 6 goes all the way across this. If we're going straight up from the top, straight down, I guess, depending which way you want to look at it, that's going to go right to the center, which means it's going to split that side in half as far as that distance. So the straight down from the top, we're going to be 3 centimeters from that side. So 3 would be one of the legs of our triangle. So once we have that set up, 3 squared, 3 times 3 is 9. 12 squared, 12 times 12 is 144. So solving for h here, they're adding, we can subtract 9 on both sides. And then h is being squared, we need to do the square root. Technically, square root, we put plus or minus, but once again, square root can't be negative. Now, square root of 135, if you put that in your calculator, it does not come out evenly. So what I'm going to do, rather than writing that decimal down and then having to deal with that the rest of the problem, I'm just going to keep it here. So I'm just going to keep this as square root of 135. And then if you want to, we can actually multiply across. Denominators, if we multiply across, we'll get 3. Since the square root of 135, it's under a square root, we have to keep that separate. So we can multiply these numbers together. 1 times 6 times 6 is 36. And then that's times the square root of 135. All right, at this point, you can actually take 36 times the square root of 135. If you want to, go ahead and get that answer and then put divided by 3. And then we're just going to round this off to the nearest tenth. They really didn't tell us what to do here, but that's what we're going to do because that's what they did. And then we'll make sure we have good directions on a test. So if we round that off to the nearest tenth is about 139 4/10 cubic centimeters.